Alright, these notes cover chapter 11.5 through 11.7. Now that sounds like a lot, but 11.7 is a review section, so we'll just use that for lots of practice problems. And the first thing we'll do now is the alternating series test. Alright, so we're still talking about testing infinite summations, series from n equals 1 to infinity, where you add up the terms in a sequence. And this is a very specific kind of sequence. Its applicability is very specific. It has to look like -1 to the n. Then it has to have a positive a sub n after that. The rest of it can be any formula as long as it's positive. It has to have, though, in front a -1 to the n. That means that since the rest of it's positive, it's always going to alternate, plus minus, plus minus, plus minus. If it starts at n equals 1, it'll be negative first, then positive, then negative, then positive. Okay, that's the applicability. Now the test. If a sub n plus 1 is less than or equal to a sub n forever, that means it always has to decrease. It can't, or stay the same, possibly. It can't increase. They call that monotone decreasing. It stays the same or decreases. And eventually it has to decrease because the limit as n goes to infinity has to head down to 0. Alright, so remember before we looked at the limit as a sub n as n goes to infinity, and if it went to 0 it was inconclusive. This is a different situation, though, because it not only has a sub n, it also has -1 to the n. So if it's an alternating series and the limit of the non-alternating portion, the positive part of it, heads to 0, then it converges. So for an example, we'll take one of the ones that we saw before that diverged, 1 over n. But we'll stick on a -1 to the n. Multiply it by -1 to the n, so it looks like -1 to the n over n for n equals 1 to infinity. And there's what that would look like if you plug in n equals 1, 2, 3. You get -1/2 plus, or -1, sorry, plus 1/2, minus 1/3, plus 1/4, minus 1/5. That does converge. Alright, I went ahead and told you what it converges to. It converges to negative natural log of 2, or it would equal positive natural log of 1/2. But we don't know how to find that yet. We just know that I'll just tell you that it does. There's a way of finding that we'll be able to figure out later. But for now, all you have to know is that it does converge, and the reason it converges is because it's minus, plus, minus, plus, and 1 over n goes to 0. The limit as n goes to infinity of 1 over n is equal to 0. Here's a fancier one. It has -1 to the n multiplied onto it, and then the rest of it is pi over 2 minus the arctangent of n, or pi over 2 minus tangent inverse of n. Alright, so that's a complicated looking series, but since it has the -1 to the n, all I need to do is look at the rest of it. So pi over 2 minus tangent inverse of n. Well, I remember what arctangent looked like. That's that first picture. The first picture is just the tangent inverse of n, and it goes closer and closer to pi over 2. So if I think about pi over 2 as being that straight line, pi over 2 minus tangent inverse of n looks like the second picture. It starts out bigger. That's a bigger gap between pi over 2 and the inverse tangent, and it gets smaller and smaller because inverse tangent gets closer and closer to being pi over 2. So that limit does go to 0, and it decreases consistently. It's monotone decreasing, and it's always positive. You can't have negative numbers cropping up in there, so it converges. Now here's a new bit of terminology: absolute versus conditional convergence. The conditional convergence is when you have to have that -1 to the n portion on there to make it converge. So it's a little confusing because they don't show the -1 to the n when they define conditional convergence. Conditional convergence is in the box there. It's the summation of a sub n converges, but not the absolute value of a sub n. Absolute convergence is when the absolute value of n and the summation of the absolute value of n and the summation of n both converge. So we're going to need to see some examples of those. I'll do that on the board. Next up, ratio test.